Hello everyone, welcome to Enviro Pioneers. In this video, we will learn behavior of the sound waves as these waves travel away from the source of their origin. So during the propagation, when the sound waves encounters the end of the medium or any obstacle, there is possibility that this sound can either be reflected or it can be absorbed or transmitted or diffracted. So several phenomena can be seen as the behavior of the sound waves, that is the reflection, refraction, absorption, transmission and diffraction. So we will see all these phenomena one by one in detail. So let us start with the reflection. Like the light, sound also gets reflected from the surface of the solid or the liquid medium following the laws of reflection, and it mainly occurs when a sound wave encounters a boundary between the two media and then bounces back into the original medium. So depending upon the type of surface on which these sound waves are incident, the reflection, it may be of two types, specular reflection and the diffuse reflection. So specular reflection, it mainly occurs when the reflecting surface is smooth and it is large in compared to the wavelength of the sound waves. So in this case, it follows the law of reflection where the angle of incidence is equal to the angle of reflection. So here we have the incident sound wave and this is the reflected sound wave. And the diffuse reflection, it mainly occurs when the reflecting surface is rough or it is small in comparison to the wavelength of the sound waves. So the example which is mentioned here is the acoustic foam. So here we can see that this is the irregular reflection, means the angle of incidence is not equal to the angle of reflection. Reflection of the sound waves is also affected by the shape of the surface on which these waves are incident. Here in this image, the blue lines are representing the incident sound waves while the red one are representing the reflected sound waves. In all the four cases, we are having the specular reflection, but we can see that in each of the cases, the direction in which these waves are getting reflected that vary. In the first part here we have a plane surface and we can see a uniform reflection, that is the specular reflection. And then second part पे यहाँ पे convex surface है and depending upon at which particular point these waves are incident, the reflected waves are getting spread in more and more area. जो concave surface है, here the reflected waves are getting focused on a particular point. And if it is a corner surface, we can have a multiple reflection, and depending upon at which particular point this wave is incident, accordingly the direction of the reflected wave will change. Curved surfaces with the parabolic shape, they focus the sound waves to a point spot. यानी कि जहां पे भी हमारा इस तरीके से स्ट्रक्चर होगा, कनकेव सरफेस और द पैराबोलिक शेप, जहां अंदर की तरफ से साउंड वेव्स इस पे इंसिडेंट है, तो उस केस में रिफ्लेक्शन विल बी इन सच ए मैनर दैट द रिफ्लेक्टेड वेव्स विल बी फोकस्ड ऑन अ पर्टिकुलर पॉइंट. So that is referred as the focal point. This concept is utilized in some of the museum exhibit where the sculptures are made of the parabolic shape. And this parabolic shape, it amplifies the sound by reflection because the incoming sound, it gets reflected from the surface of this vessel and it gets focused at a single spot which is referred as the focal point. And at this particular point, the sound is amplified. So suppose if we place our ear at this particular point, we will be able to hear the faintest whisper in the form of the loud and clear sound. And the seats in this particular vessels are designed in such a manner that if a person is sitting on this particular seat, his or her ear are at the height of the focal point. So अगर हम इस particular seat पे बैठे हैं, then in that case we will be able to hear the faintest whisper if there is any in the room. Reflection is also used to focus sound in a stethoscope, megaphone, or when we are calling someone by placing our hand around our mouth. So in the stethoscope, here we have a section of the rubber tube, and in this tube we are having the multiple reflection of the sound. When we are using the megaphone, it is designed in such a manner that the sound waves, it undergo multiple reflection and then it is getting reflected in the forward direction. In the case of specular reflection, the sound is reflected from the surface at the same angle at which it strikes the surface. Suppose if we have a parabolic structure behind the source of sound, the reflection is in such a manner that the reflected waves are moving parallel to each other and it moves uniformly in the forward direction. This concept is used in designing the amphitheaters or stages in the big hall जहाँ पे large audiences को address करना होता है. So behind the source of sound, a curved wall is designed so that it acts as a sound reflector, and whatever sound is getting generated at this particular point, it will be getting reflected in the more uniform manner and it will be audible to all the persons sitting in the hall. This is also the basics behind the whispering gallery, which are known for their unique acoustic, where whisper can travel long distances and it mainly happens beneath a towering dome or a vault which is having the circular or the elliptical enclosure. So if a person is sitting here and is saying something, it can be heard across the gallery. Some of the famous whispering galleries include the one in the St. Paul's Cathedral in the London, the one in the Gol Gumbaz Mausoleum in the Bijapur, and one is the Whispering Arc in the Grand Central Station in the New York City. There are many more, and if you have interest, you can visit these two sites where you can find the compilation and details of the whispering galleries. When there is reflection of the sound waves from the surface, there is possibility of two phenomena. Either it can be an echo or it can be a reverberation. So reverberation, it is mainly the reflection from the nearby walls, and the echo is reflection from a distant wall or from a distant cliff. So here in this animation we can see that the first one is the reflection of a nearby wall, and here we are having the reflection from a distant cliff. So the important point to note here in this animation is the time. So when we are having the reflection from the nearby wall, we can hear the reflected sound within zero point 0.1 second. But in the second case, the time taken by the wave to return back to the listener is 0.36 second. So what is the difference between this echo and reverberation? A reflected sound is said to be an echo when a pulse of the sound it can be heard twice or thrice depending upon the number of reflection, and each of the reflected sound is perceived by the brain as a separate events, and the intensity of the sound decreases with each of the reflection, while the reverberation, it is the reflection where the sound is perceived as the single sound and it is the prolongation of the original sound. So reverberation is defined as the persistence of the sound after the sound source has been stopped, and it mainly results from a large number of reflected waves which can be perceived by the brain as the continuous sound, not as a separate sound. So here it is mentioned that an echo can be heard only when the distance between the source of sound and the reflecting body is more than 17 meter, while the reverberation it occurs in a small room with the height, width and the length dimensions of approximately 17 meter or less. तो अब ये 17 meter कहाँ से आया? So in the case of echo and reverberation, two things are important. First is the time and second is the distance. Okay. So जो हमारा human brain है, that can keep a sound in memory for up to 0.1 second only. So if a reflected sound, if it is reaching our ear within the 0.1 seconds of the initial sound, then it seems to us as the prolongation of the original sound. But if it is reaching after 0.1 second of the original sound, then in that case हमारा ब्रेन इसको एक सेपरेट इवेंट की तरह कंसीडर कर रहा है, एक सेपरेट साउंड की तरह कंसीडर करता है. So when we are hearing the reflection after 0.1 second, then in that case it is the second sound for our brain. So this is the important thing कि अगर कोई भी reflection within 0.1 second के अंदर वापस हमारे ईयर को पहुंच रहा है, then that will be the reverberation, because that will be perceived by our brain as the prolongation of the original sound. अब इस टाइम को यूटिलाइज करके हम डिस्टेंस कैलकुलेट कर सकते हैं, बिकॉज जो रूम टेम्परेचर है इस पे जो साउंड वेव्स है दैट ट्रेवल एट अबाउट 340 मीटर पर सेकेंड. नाउ यूजिंग दिस थिंग वी कैन कैलकुलेट द डिस्टेंस, क्योंकि जो स्पीड है दैट इज इक्वल टू डिस्टेंस बाय टाइम. सो इफ वी हैव टू कैलकुलेट द डिस्टेंस इट कैन बी कैलकुलेटेड यूजिंग स्पीड इनटू टाइम. सो यहाँ पे हमारा ये 340 स्पीड हो गया एंड टाइम वी आर टेकिंग 0.1 सेकेंड. So on this basis, if we are calculating, this is the 34 meter. But this is the total distance which is covered by the sound from the point of generation to the reflecting body and then back. तो ये 34 मीटर इन टोटल डिस्टेंस है. तो अगर हमको कैलकुलेट करना है कि जो रिफ्लेक्टिंग वॉल है वो ऑब्जर्वर से कितने दूर है, देन इन दैट केस इट विल बी हाफ ऑफ दिस. तो ये हो गया हमारा हाफ ऑफ दिस 34 विल बी 17 मीटर. सो यहाँ से हमारा ये 17 मीटर आता है कि जो ऑब्जर्वर और रिफ्लेक्टिंग वॉल है इसके बीच का डिस्टेंस हमारा 17 मीटर होना चाहिए. एंड दिस इज द रीजन दैट रिवर्बरेशंस आर कॉमन इन द रूम्स हैविंग द डायमेंशंस ऑफ अप्रोक्सीमेटली 17 मीटर्स और लेस, because जो multiple reflections हो रहे हैं from the walls and the ceilings that are reaching to the observer within the 0.1 second of the original sound, and it causes the reverberation, that is the prolonging of the sound. And for the distant echoes, यानी कि अगर जो reflected sound है अगर हम उसको एक second sound की तरह सुन पाए, उसके लिए the minimum distance of the reflecting wall from the source of the sound, it must be more than the 17 meter. So here we can see here a person is standing and is shouting to produce the sound. So this is the original sound, and then the distance between the person and the reflecting wall is 17.2 meter. So जो reflected sound है that will produces the echo. But this distance, it may change with the temperature of the air, because the speed of sound, it is dependent on the temperature of the medium. And if there is higher temperature, speed of sound is more. If it is lower temperature, speed of sound decreases. So depending upon the conditions provided in the objective question, you will get that at particular temperature, the speed of sound is this much, और आपको एक minimum distance calculate करना है. So using the same formula, you can calculate the distance at the provided speed, और जो distance आपने calculate किया उसका जब आप half करोगे, that should be the minimum distance between the reflecting wall and the observer. And depending upon the successive or the multiple reflection, the echoes can be heard more than once. Next is refraction. So when a sound wave is propagating and it is incident on the second medium, some portion may get reflected and some may travel from one medium to another medium. So when it is moving from one medium to another medium, these sound waves bend from the original direction. So in this case, the direction as well as the speed both changes as it moves in the second medium, depending upon the properties of the object or the material as well as the temperature. Here we have the representation of the refraction and the change in the speed. So here in the medium one, the speed of the sound is more, and that can be seen here as the distance traveled by the wavefront in unit time at the speed v1 is more. But as it crosses the medium, the direction also changes and the speed also get lessened, because the distance जो ये अभी sound इस medium में travel कर रहा है in unit time, that is much less in comparison to this. In the shallower water, the sound wave travel slower, because the bottom of the wave they interact with the seabed, which causes the friction and decrease in the speed. Even though the sound wave is not changing the medium, और अगर ये same medium में continue कर रहे हैं, but if the medium is having the varying properties, then also the wave will encounter the refraction and change in the direction. इसका best example है the sound propagation in atmosphere. In atmosphere, the temperature of the air may vary, and this temperature variation, it may be because of the temperature gradient generated during the day or night, or because of the presence of the water body. So suppose here we have the example that this is the surface water body. तो जो water है इसका एक moderating effect होता है on the temperature of air. यानी कि air which is just directly above the water, it will be cooler in comparison to the air which is far above the water. So here we have this representation कि यहाँ पे हमारा surface water body है and then the air which is just above the surface water body, that is represented here as the cool air, or above a certain height this is the warm air. Suppose there is source of sound in near to the water body, तो यहाँ पे जो sound generate हो रहा है, तो sound waves will propagate in the spherical manner. When it is in the same medium or within the same temperature range, तो इसका जो speed है that will be uniform. But when these wave fronts encounter the temperature variation, so जो portion cooler air में है, their speed will be less and it will travel the lesser distance. But जो portion warmer air में पहुंच गया है, there the speed of the wave will increase and it will travel the larger distance, and because of this the direction of the wave it changes, refracting downward towards the water. Now coming to the absorption and the transmission. So when the sound waves are incident on a particular material, some portion is reflected, some portion may get absorbed and some portion may get transmitted. So the absorption, it mainly occurs when the sound wave is absorbed by the object or the material it encounters, and the sound wave which is absorbed by this material, it is transformed into the heat energy inside the object. Amount of energy that is absorbed by the material, it depends upon its thickness as well as the nature of the material. So there are some material which absorb more in comparison to the other, and if there is very little absorption, it causes the sound either to reflect or to transmit. So this transmission, it takes place when the sound wave is transferred from one material or medium to another, and then it continues to travel on the other side. So some portion will get absorbed here, and whatever is not absorbed, it will be transmitted to the other side. And this transmission, it depends upon the acoustic impedance of the two material. So this acoustic impedance, it is the measure of the material's resistance to the propagation of the sound wave, and it depends upon the density and the speed of sound within it. And this transmission, it becomes problematic when the sound getting generated in one room, it is traveling through the wall and is getting heard by the people in the next room. And last is the diffraction. Diffraction is the bending of waves as they pass through the narrow openings or around the sharp corners. So here in this image we can see that as the wave it passes through the gap, it spreads out in the forward direction. Likewise, when it encounters the sharp corner, again here we can see the spreading of the waves. So all the waves can be diffracted, but this diffraction, it does not affect the speed, wavelength or the frequency of the sound waves. But this diffraction, it is dependent on two things. First, the wavelength of the sound wave, and the second is the aperture through which these waves are passing. So the amount of diffraction, it increases with increasing wavelength and it decreases with decreasing wavelength. So shorter is the wavelength of the sound wave, lesser will be the diffraction, and if it is having the longer wavelength, there will be more diffraction. And if the waves are passing through the large aperture, so there will be low level of the diffraction, but if it is passing through the small aperture, there will be high level of the diffraction. These are the references from where the content of this video has been taken. Thank you for your continuous support. We will meet soon in the next video. Thank you.